All right, guys, this lesson is going to take us back to the last unit. Looks like we missed a little bit of the concept that we're going to be covering in this lesson, which is percent of change kind of stuff, which goes better with Unit 9. But, yeah, it looks like the lesson was changed on us, that homework, and so I taught according to the homework that we had instead of the one that was changed. So got to make that up on this assignment. That's what we're going to do. But first is Bellwork. It says William's car used 2 gallons to travel 68 miles. How far can he travel on 9 gallons? So this is going to be a proportional relationship. We're going to assume that the same rate that William was traveling with these 2 gallons and 68 miles will be the same rate for the 9 gallons. Now, for this, though, we have the 2 labels, right? We have gallons, and then we got miles that we're comparing. And so for me, I'm just going to start with the gallons. That's the first label that showed up right here. I'm just going to show it as GAL, and I'm going to put it in the numerator. So since I have that in the numerator, I will keep it in the numerator. Remember, that's the whole point with those, is to maintain where you put your labels, and then I will put miles in my denominator. So if it's going to be like that for the first fraction, it needs to stay that way for the second fraction as well. Now that I know where the labels are going to be, I now look at the numerical values that accompany those labels, starting, for example, with these 2 gallons, which says that using those 2 gallons produced 68 miles of travel. So that gives us our first fraction. And then next up, we see that how far he can travel is the question. How far can he travel on 9 gallons? So I already see where my label is for gallons, and I just need to apply the 9 to it, which means that we need to figure out how many miles that's going to be. Now, whatever method you use on this is fine, but I'm partial to fish method, so that's what I'm going to do. And whatever method you use on this, you should get the same exact answer. Remembering you got the 4 values, and it's always multiply, divide, and it should equal whatever the unknown is, which for us is going to be that x right there, okay? So remember, you make it tell the fish, starting with the letter, you go up to or down in other cases to the first number, which in this case is showing as 9. I cross down here to the 68. I make the head of the fish coming back up here to the 2, and then I finish off where I started at x. That's the fish. And this is just something I'm going to put in my calculator. It's 9 times 68 divided by 2. Enter, and it shows me that if we have 9 gallons of gas, assuming that it's the same rate of travel, that you're going to be able to travel 306. Remember, this is a word problem, though, so just make sure you label that answer. We don't really need to include the x as part of the answer. It's just you can travel 306 miles if you're going to use 9 gallons of gas at this rate. All right, so this is our objective for the day. I can find percent of change. Take 15 seconds and copy that down, please. All right, so this is how you find the percent of change. And it's pretty much a formula for us, but hopefully it kind of makes sense and that you wouldn't necessarily need to use the formula. What we see from this, just looking at this fraction here, okay? There's 2 parts to this fraction. You have the amount of change. So when we say we're looking at an amount of change here, that means that there's going to be 2 values given. We need to find the difference between the 2 values, okay? Now, when we say difference, perhaps I should be more specific here, but we are talking about subtraction, okay? So you just take the 2 values. Usually, when you're finding the amount of change, again, we are going to be using subtraction, but you take the big value, whichever value that is, and you subtract the smaller of the 2 values, because we don't really necessarily want to see these in terms of negatives, although you can. And if it were negative, the change would just be a decrease, that's all. But for the most part, we're looking at these as positives, and we should know in the beginning, just looking at the 2 values, if there is an increase or decrease. Okay, now one of the two values is going to be a starting value. You have to be able to determine which of those which of the two values it is. If you're looking at some kind of sell, then the original price would be the starting value, right? It's maybe where you start, okay? Or it's an earlier value. However you want to put that is up to you. But when we look at this whole fraction right here, it's going to produce a decimal value. At least most of the time it will, okay? So from this decimal value, the multiplying by 100 right here, that is strictly just to convert the decimal into a percent. Okay, so that also tells us that the decimal value tells us, again, the decimal value in change, but multiplying that by 100 changes that into a percent, okay? Now, there are other ways to do this, but generally speaking, this tends to make the most sense for students, at least it has in the past. If you have your own methods, then feel free to use those. Okay, but as long as you can find the amount of change and you know the starting value, you just divide those, change it to a percent by multiplying by 100, you're good. Now, just so everyone understands about this, because you see the percent of change, it's tax, tips, discounts, and markups. If you already know, for example, maybe how much you paid after tax and how much the total was before tax, then you would need this formula. Of course, when you get a receipt from a store, generally speaking, they always already show what the tax is. Tips may not be necessarily that case. Usually you would have some kind of amount that you want to give in tips, but then you can figure out, based on how much you gave, how much of a tip you gave, if you don't already have a percentage in mind. Discounts as well, if for some reason you have how much a sale price is for an item, and then you have how much the price was before, then you could figure out the percent of change, which is the discount percent there. But like I said, when you go to the store, usually the discount percentages are already there. Markups, not so much, right? Stores are a little bit more secretive about their markups. I don't have a problem with that. You know, they got to make a buck because they're taking all the risks having their business. But they usually get an item, they'll buy it wholesale or kind of at cost from a manufacturer, and then they'll mark the price up so that they can make some kind of profit out of it. Of course, if they're breaking even or not making money on those items, that's bad for their business. And of course, if they do that enough, they can go out of business. So they have to have some kind of markup there in order to keep their business afloat. All right, here's our first problem. And again, we're looking for the percent of change, which is what it says down here, which is also the inflation rate, okay? So be careful, you guys, because today there's plenty of propagandists that will tell you that inflation is increase in prices, when in fact increase in prices is actually a symptom of inflation. Inflation is the printing or borrowing of money. Okay, now that should make you ask questions, because in the U.S., the government borrows money, and it would be crucial for you guys to figure out who it is borrowed from. And a quick hint for you guys is the Federal Reserve. You can do some research on your own about that. But before that, according to usdebtclock.org, the national debt at 10:16 a.m. on February 24, 2022, a couple weeks ago there, was $30,148,435,746,179. Now, it could just be me, but it seems like that would be a lot of money right there, just to me, okay? But if it's not you, then so be it. Well, yeah, this is a screenshot of what that looked like at 10:16. Of course, it was changing throughout just the minute there, 10:16. So this was at a specific moment at 10:16 on February 24. But it says 10 years earlier, that would have been 2012, it showed the debt at $14,941,820,097,249, which again, to me, is still quite a bit of money. So if we're going to find the percent change, the first thing we want to do is to figure out the change. which on the last slide we said is the amount of change, right? So if we can do this, figure out the amount of change, then we can at least start our fraction, right? So let's just take this value, because again, that's the big value there, the 30 trillion and a lot of extra change. And the smaller value for us is this 14 trillion and some change as well, okay? So I'm going to subtract these because that's how we find change. It's the difference between these. And you can do this place value by place value. And if you did this, because I think these numbers may be too big for the calculator, but I'm going to start on the ones place value. 9 minus 9 is 0, 7 minus 4. I'll borrow there. It's 11 minus 2 is 9. Again, borrowing. 15 minus 7 is 8. And then borrowing again. 13 minus 9 is 4. 6 minus 0 is 6. 5 minus 0 is 5. 3 minus 2 is 1. I'll make that 14 minus 8 by borrowing, which makes that 6. 7 minus 1 is 6. 4 minus 4 is 0. 1 minus 9, I'll make that 11 by borrowing from the 30 instead, making it 29. 11 minus 9 is 2. 9 minus 4 is 5. And 2 minus 1 is 1. Okay? So this means that between 2012, which was the $14 trillion figure, almost 15, to the $30 trillion figure, the U.S. government borrowed $15,615,648,930. Okay, and again, this is our amount of change. So I'm going to take that number right there, our $15 trillion figure, it's very large, and I'm going to now divide that, and I will use a fraction line for this, by the original figure, okay, which was the first one, okay? That would have been 2012. That's the number we're comparing it from the beginning. The starting value for us is the 2012 figure. Very large number there, okay? So let's take that number. Let's see if it'll, yeah, there we go. I copied it. I'm going to divide that, okay? Now, even though these numbers are large, the calculator should allow me to do this. 15,206, 615, 648, 930 divided. And I'm using the divide button, not the fraction button there, but 14, 941, 820,097, 249. And when I push enter here, I get this decimal. And I won't show all the decimal places on my calculator. I'm just I'll round it to the nearest, you know what, I'll go to the nearest hundredth. So that's 1.0, I have 177.21774. And so I'm just going to round that to 0.2, okay? Now, just so we remember from the last slide, this is the percent of change as a decimal, okay? In order to change this to a decimal, or to a percent, I need to multiply this by 100, okay? There we go. So that is what I will do. I will take my 1.02. A little spoiler alert there, I suppose. But now I'm going to multiply that, as we say right here, multiply by 100. And yeah, I guess there's no need to round this because of the way that I already rounded the decimal, but that comes out as 102%, okay? Now, just real quick, what this means, and this is our answer, this is all we need right there for this problem, but just to clarify what this means. Okay, so between, we'll say February 2012 and February 2022, Again, this is the government borrowing this money. 102% of the already existing national debt. Now, if that number seems too glorious for you or too exaggerated, you're welcome to go and do your own research on the numbers that I'm using here. These are just screenshots from the U.S. debt clock. So on the 24th of February, I just took the screenshot, and then I used the debt clock time machine to see what that debt was on this day, which I believe is supposed to be at that exact moment. But I can't confirm that. Again, if we're just using estimates, you could have just rounded these numbers as well. But we see that, again, the government borrowed that much of what was already existing in terms of the national debt. Now, the interesting thing about this U.S. debt clock is that you can also see some other interesting figures that are given here, like the amount of debt per citizen, I guess for local and state. Yeah, and by the way, this is not actually all of the U.S. debt. The number you're seeing here are just what we call funded obligations, as far as I understand. But in actuality, the unfunded obligations, which would be something like pension funds for government employees and such, is over $100 trillion. So it's actually more than that. But again, we're just kind of using this directly to show a percent of change. And again, these numbers, I think you guys are too young to really be fully astonished by the numbers that we're seeing here. But whether you are now or later doesn't matter. Eventually you will be, because this stuff has a great bearing on your life. In other words, what I'm trying to tell you guys is this is actually one of those lessons that is important in life. I think I've told you guys several times that a lot of the math that we use isn't really so applicable in life. It's not very useful. But this is one of those that is. And if you can find percentages of change, it's a great way to determine inflation rates. But also, I know people that trade stocks use them quite extensively as well. You can do your own research on how that's done. But again, I think this is pretty crucial stuff. You may not feel so right now, but whether you do now or later, doesn't really matter. Eventually you will, because it affects you whether you know about it or not. All right, here's his next question. Hudson went shopping for a new pair of sneakers. The listed price of the pair of sneakers was $29, but the price with tax came to $31.61. Find the percent sales tax. Okay, so a sales tax is a percent of change. So like I said, generally speaking, you would know already what the tax percentage is, especially if it's some kind of sales tax. Geez, I'm trying to think if there's any other kind of taxes. Of course, there's a lot of other taxes, but they all kind of are grouped under a sales type tax. Whatever the case is, we see that Hudson here is going to go shopping for a new pair of sneakers. Listed price was $29, but after tax, it comes out to $31.61. We need to find the percent sales tax, okay? So for me, let's look back at that formula. All right, so this is what I got, and I want to start by finding the amount of change, okay? So let's find the amount of change. I'm just going to take the big number here, $31.61, and I'm simply going to subtract the $29, okay? And again, this is going to give me my amount of change. I'll put this in red, and yeah, it's $29. If you need the decimals there, then keep them. But you should be able to subtract this either way and get $2.61. Okay, now the amount of change in this case is the actual tax in dollars. Okay, meaning that the original price was going to be $29, but after tax, there was an additional taxing charge of $2.61. Now, again, the importance of this lesson, I just can't stress enough, because you should ask questions. Why am I being charged for purchasing, or why is anyone being charged for purchasing sneakers? Because tax, you would assume, goes to the government there. Again, this takes a lot more research than what I'm giving you here, but why are you paying $2.61 to the government for purchasing a pair of sneakers? If that makes sense to you, that's okay, but I have lots of questions about that stuff, okay? Now, that's just the amount of change. And so I'm going to go back to my formula right here, and now that we know the amount of change, let's replace it with that $2.61. I don't really need the label there. And then we're going to look at the starting value. Well, what was the price before we were taxed? Well, that's showing as the $29, right? So my starting value, I can now go in and replace with 29. And again, this kind of becomes a formula for us. So what I mean here is you can really just type this in exactly like we see it. I'm talking about all this stuff right here, okay? So my calculator, right? I say 2.61 over 29. And I can even use the N over D button right here and multiply it by 100. I got to get another fraction before I multiply 100. But when I do, I can push enter, boom. It shows me that the percent of change here, just from putting that in the calculator, is 9%, okay? So again, that means you're going to be taxed here on, Hudson gets taxed 9%. Yeah, that seems kind of high to me, but I could be wrong. I believe for oil tax, what are they at, like 15% last time I saw, or something like that. And so just to clarify, I boxed in the formula here. That's all that is, but the actual answer is 9%. How about this one? Jason invests money in an account paying simple interest, which I don't know of any accounts that work that way, but it's going to make it easier for us. He invests $160 and no money is added or removed from the investment. After 1 year, he has $164.80. What is a simple percent interest per year? So, again, they're saying simple percent interest right here. It's just the percent of change. That's all they're asking for. So don't be too fooled by the words, just like taxes, percentage change. Same with this simple interest type problem, okay? So let's look at the formula then. So our formula, there it is, I found it. It's kind of big, but it'll work. Let's go ahead and figure out how much it did change for us. So the amount of change, right, is where we take the biggest number, which in this case is $164.80, and I will be subtracting the $160, which isn't showing a decimal, but we can add one onto it with the 0.00 there. Let's go ahead and subtract these, okay, because that is going to tell us how much it did change, which when you do, you can use a calculator for this. You don't have to do it by hand like I'm doing right here. It's $4.80 right there, okay? Now, this $4.80, really what this is it's the amount of interest Jason made from having the original $160 in the account. Okay, make that a little bit bigger. There we go. So, in other words, Jason makes $4.80 just by having the money in the account. Well, again, what percent of interest is this? Well, let's go back to our formula here, right? We know that the amount of change is now $4.80. Let's replace that there. And what's our starting value on this one? Well, starting value is how much he had invested in the beginning, which is showing as that $160. So that's going to be my denominator here. And again, I'm just going to put this in my calculator, see what I get. And like I said on that last problem, I used the N over D, right? So that's 4.80 over 160. Make sure you get out of the fraction button, fraction if you're going to use the fraction button, multiply by 100. Oh, this one comes out as just 3. Okay, so the percent of change, again, I'm not just going to put 3, it's a percent, right? So make sure you actually label that in percent. So in other words, Jason's interest rate here per year would be 3%. Now, just so you know, if you have a bank account or your parents have a bank account, whether it's savings or checking, As far as I know, both of those have some form of interest that you make from having your money in the bank, but it's not usually at 3%. It's usually something that's very low, and investing at 3% really is not going to change your life, unless you're some kind of millionaire, which, hopefully that happens for you. But for most people, just putting in like maybe $1,000 in the bank, 3% is not going to really make any big changes for you. But keep that in mind when you put money into the bank. They have what they call fractional reserves, and that's where they get a lot of the money to loan from. So, for example, if you put $160 in the bank, at least last time I remember seeing, they could actually and then loan $1,600. It's a 10-to-1 ratio. So for every dollar you put into the bank, they can then loan $10 out, which is another form of interest, which is another form of inflation, rather, because the money supply continues to rise, whether it's being printed or borrowed or through a fractional reserve like this. Okay. Now again, I'm giving you guys a lesson that's bigger here than just percent of change. And the more research you do, the better off you're going to be. All right, for this one, Josiah has a loyalty card good for a discount at his local grocery store. The item he wants to buy is priced at $21 before discount and tax. After the discount and before the tax, the price is $18.27. Find the percent discount. Now, just to be clear, when they say percent discount, they're really talking percent of change. Now, it being a discount, though, it means that it's a decrease. Okay, now we know it's a decrease because the original price was at $21. We're going to need the original price when we put this into the formula, and then the new price is $18.27. See, it went from something big to something smaller. Or just something to something smaller. It doesn't matter if it's big or small to start with, as long as it shows some kind of decrease. That'll be important later, although right now we're not too concerned about it. But if we look at our percent change formula here, see if I can get some. There we go. Let's make this a little bit smaller. Again, can we find the amount of change here? Well, of course we can. And that will be our numerator. So my amount of change, again, we're just going to take the big number and then subtract the small one. The big one here is $21. And I'm stacking these for subtraction. The next one is, the small one is $18.27. So I do have cents from the $18. So I'm just going to show 0.00 for 21, at least if you're going to do it by hand. Actually, I did that just to show that we do have decimal place for the 21, but actually, I'm just going to use a calculator. So 21 minus 18.27, it shows me that would be $2.73. Okay, now again, just to be clear, it's $2.73. That's the amount off of the original price of $21, right? So it used to be $21. They took off $2.73, and then the discounted price, $18.27. So I can go to my formula now, and I can replace my amount of change there with a value that we found for the amount of change at $2.73. Okay, but do we also now have the starting value? Of course we do. We know that it originally started at $21. Okay, so I'll put a 21 there. I'll plug this into my calculator, including the multiply by 100. Yeah, and this time I'll use the division button. So 2.73 divided by 21. And I can just multiply straight as 100, and it shows me the percent of change here as 13. Okay, so it's a 13%. Just to be specific, it's a 13% discount as our percent of change. All right, here, Claire was out at a restaurant for dinner when the bill came. Her dinner came to $26. After adding in a tip before tax, she paid $29.12. Find the percent tip. So we're just looking for the tip here. In fact, they said, hey, Here's before tax. Just ignore that. Just kind of like we did on the last problem. Although I didn't say that explicitly. Yeah, let's ignore the tax. We're not concerned about that. Sometimes you'll see in math problems, they'll throw that in there just to see if you'll get confused by it. But don't. It's not really relevant to what we're solving right here. So, but what we do need, though, right? We do need our formula. So let's see it right here. Amount of change divided by starting value times 100. And they did say to find the percent tip, right? Remember that your percent tip is a percent of change. Okay, so that's why we're using the formula there. Let's start with our amount of change. Okay, so we're finding how much it changed from where the dinner started and where it ended. And we just take the big one, which in this case is the $29.12. And we will be subtracting how much it started at, which is just a smaller amount, really. That's all we really care about there. We're going to subtract that, okay? So I'll show the decimal there. Again, if you want to do it by hand, it doesn't really matter. Ultimately, we see that it ends up being an additional $3.12 for wherever it started, okay? So this is just the amount of the tip. Okay, so Claire, she gets this dinner. She gives a tip of $3.12. Now, just so you understand, because I did work in the gratuity industry where tips are common. I delivered pizzas for over 2 years. $3.12 sucks. It's a sucky tip. So pretty much anything below $5 is a sucky tip, and you just got to be careful going back to those places because you start tipping real crappy, eventually they will get you. So it's a $3.12 tip. So yeah, let's go back to our formula, right? The amount of change we now know is $3.12. Let's go and put that into our formula. $3.12. Well, let's compare that. We're always comparing these to the original value or starting value, which we know. Starting value was how much the dinner was before any taxes or tips, which was 26 bucks. So 26 right here, yeah, that completes the formula. Let's go ahead and figure out what that is using the calculator. I'm just going to straight divide this one. 3.12 divided by 26 times 100. Enter. And it says and that's not even a bad tip, by the way. I'm not saying it's a bad tip. 12% really is not that bad. It's just pretty much anything below $5 is it's just not great. So there you go, 12% tip. Be kind to your waiters and waitresses or delivery people because they're not getting paid very much when they're working off tips. 1 year, the population of a city was 335,000. Several years later, it was 314,900. Find the percent decrease. And this one's telling us that it is a decrease because we see it started at something higher than where it ended right there. Very generous of them, although we didn't necessarily need it. But now that we have it, all right, fair enough. We now know it's a decrease, right? Now, a percent decrease is a percent of change, just specifically in the negative direction, in the downward direction. And so we can figure out our values here. Let's find the amount of change, which, again, we're just going to take the bigger of the two values. Doesn't matter which one starts at. We're going to start with the big one, which is 335,000, and we're going to subtract the smaller of the two numbers, which is 314,900. And if for some reason you feel ashamed, like, I can't do this by hand, don't worry about it. That's all I'm going to do. And I do feel comfortable doing it by hand. I just don't really care to do it. So 314,900. And so it looks like this one, when I put it in my calculator, it says that the change was 20,100. Now, that's the amount of change, right? But let's be again, a little bit more clear here. This was the decrease in population. Was this much, the 20,100 people, okay? So in other words, between whatever years I guess this is, the city lost 20,100 people. Maybe they moved out, maybe they passed away, who knows? but the population has lost 20,100 people. Well, as sad as that may sound, or as sad as you may want it to sound, it's we're just doing this mathematically. So the amount of change we have now for the formula, 20,100. Okay, that's the change, and even though it's a negative, it's a decrease. We already know it's a decrease. So again, if we took the ending amount, subtracted the original, then we would have ended up with something negative, which would tell us it's a decrease. That may not make a lot of sense right now, but it doesn't have to. So the starting value, though, well, it started at 335,000 people in the city, so let's go and put that in. So there it is in our formula. This will help us to find the percent of change. I got 20,100 divided by 335,000, and I'll just multiply that by 100. Okay, well, that's a 6. My calculator just came out with 6. That's a 6% decrease. And again, if we just want to be more specific here, we'll say in the population. Okay, there we go. 6% decrease in the population. That came out pretty nice. We didn't see any need to do any rounding in this assignment except on the dead clock from the first example, but that's pretty good. All right, there's our objective for the day. I can find the percent of change, which is, yeah, we're just using this formula that we've been using the whole time to do that. All right, so go ahead now that you watched the video, go and start on the assignment. And good luck on that one. You should be able to finish. If you don't finish before class is over, you'll have to do it at home. Or you can wait until Friday, which is pretty much a free day to get stuff done, okay?